Namaskar. Uh, Now we will discuss what is the surface integral and how to calculate the surface integral. The term integration over the surface a bar dot ds bar is known as surface integral. To calculate this surface integral, we should know the function a bar, which is the vector function. Let we will consider the function to be x square y I cap minus 2yz j cap plus xyz k cap as the vector function. To integrate it over the surface, we need to fix the surface. Correct? Now here I will let you know the surface in Cartesian coordinate system. This is the Cartesian coordinate system, and I will choose the surface which is something like this. Correct? Which is something like this. Now the surface is parallel to xy axis, and along y axis its length is 5, therefore it is a rectangular parallel to xy axis with length 5 along y axis, breadth 4 along x axis, and it is at height of 3, say for example above the xy plane. This is my surface over which I will have to integrate. Therefore, what is the speciality of this surface? As the surface is parallel to xy plane, in Cartesian coordinate system we have observed that the surface element will be dx dy and it is along k cap. Now there we have observed either I can think about along k cap or minus k cap. It depends on the situation. Now as the surface is the upper surface, in this case I will assume that it is moving along, or not moving, its unit vector is along z axis, that is plus k cap. But suppose it is the surface, bottom surface, it is in xy plane, then I may have considered it at minus k cap. Correct? Okay, fine. Now what is this surface? For this surface the value of z is equal to 3. That means everywhere on the surface z is equal to 3, because this plane or this surface is parallel to xy plane and cuts the z axis at z is equal to 3. Therefore, for every point on the surface z is equal to 3. And now we will begin with the solution of this surface integral. What I will have to do? I will have to integrate. But see, actually there is a integration over two terms, it is dx and dy. Though I have yet mentioned it is surface integral, and therefore to the line I will have to mention that it is surface. That means actually it is the integration over two variables. If it is volume, it is three variables. If it is line, it is single variable. And therefore now I will write it is surface integration. That means two integrations of. I will write a bar, that is x square y I cap minus 2yz j cap plus xyz k cap dot, and what is the surface element? Surface element is dx dy and it is k cap. Correct? Dx dy k cap. Okay, then I will solve this dot product. The solution of dot product is as usual. There is no coefficient of I cap, that is 0. Coefficient of j cap is also 0. Therefore, these two terms will vanish. And as there is finite coefficient of k cap, that is dx dy, only this term or this dot product will remain as it is. Therefore, it is xyz dx dy. Now if there is no bracket, if we don't use any bracket, then the convention is that the order of variables and order of integration will be same. Therefore, while writing the limit, upper and lower limit, first of all I will have to write the limit for x. Now here x varies from 0 to 4, therefore I will write here it is 0 to 4. Y varies from 0 to 5, and therefore here I will have to write it is 0 to 5. Means it is integration of xyz over x from 0 to 4 and over y from 0 to 5, and keeping z to be constant and it is equal to 3 because our surface is at z is equal to 3. Okay, fine. Now it is not possible to solve both the integrations simultaneously right now, and therefore I will calculate or I will integrate first over x, say for example. Therefore I will write here it is integration 0 to 4 over dx of what? Of x, y, z. But now z is equal to 3 and therefore I will write it is 3xy, and then I will have to integrate over y from 0 to 5, therefore it is integration 0 to 5 over dy, correct? And now it is very simple to solve this, therefore I will keep the integration 0 to 5 dy as it is. And what is the integration of 3xy over x? It is 3y x square divided by 2 from 0 to 4, because when I am integrating over x, I will have to assume y to be constant, and therefore it is 3y is the constant. Integration of x is x square divided by 2. Upper limit is 4, lower limit is 0. Now as the lower limit is 0, it is a bit simple, but if lower limit is non-zero, then what we will have to do? We will have to substitute the upper limit. Wherever there is x, I will have to substitute 4. Wherever there is x, I will have to substitute the lower limit if it is non-zero, and then I will have to take the subtraction. But in this case, only upper limit is to be considered. Therefore 4 into 4 it is 16. 16 into 3 is 48 into y. Therefore it is 48y, and then integration from 0 to 5, this integration and into dy. Therefore the next term is 48y dy and integration from 0 to 5. You may check once again. 4 into 4, 16. 16 into 3, it is 48, is fine. Now this is very simple. Again it is 48 integration y over y is y square divided by 2, 0 to 5. Therefore upper limit and lower limit I will have to substitute, and that is equal to 24y square from 0 to 5. Again in this case upper limit is 5, no need to substitute the lower limit as it is 0. Therefore it is 25, and hence it is 24 into 25. This will be the answer. Now in this case I had considered the surface parallel to xy axis and at z is equal to 0. You may think about the different surfaces, correct? And suppose there is a rectangle, something like this. Suppose, or it is a rectangular box of length 4 along x-axis, width 5 along y-axis, and height 3 along z-axis. Then you may calculate the surface integration of a bar over the top. That means that we have considered this over the bottom surface. For the bottom surface, dx dy remains as it is, but we will have to assume k cap to be minus, that is minus k cap, direction will be around. Therefore for this the surface will be dx dy plus k cap. For the lower it will be dx dy minus k cap. For the right surface we can say that it is parallel to xz plane, therefore this will be dx dz and it is along y cap. For the left surface it will be same dx dz but minus, this is dx dz but minus j cap. For the front surface, for this front surface it will be parallel to yz plane and therefore it is dy dz I cap, and this for the back surface it will be dy dz minus I cap. Therefore now with the same function a bar, as a homework you can calculate the surface integral over remaining 5 surface. We have considered for the top surface, and now you may think about the integration for remaining 5 surface. Obviously I will give you one more homework. As a homework, let the function will be, okay, this is homework, let the function b bar is equal to x square y cube I cap plus y square z j cap minus x z square k cap. And you may think about the surface integral over all the surfaces of a rectangular box, which is something like this. This is the rectangular box. Okay, I will treat the rectangular box which is here. That means it is not beginning from the bottom, that is xy plane. It is somewhere here. Now I will give you the coordinates of this point. Coordinate of this point. Okay, first of all I will write the coordinate of this point. It is say for example this is 3, this is equal to 4, this is 2 and this is 2. Therefore coordinate of this point will be x is equal to 3, y is equal to 0 and z is equal to 4. Correct. Whereas coordinate of this point x is equal to 3, y is equal to 0 and z is equal to 2. That means it is the rectangular box but not kept on the xy plane. It is slightly above it. Coordinate of this point, it is x is equal to 0, y is equal to 4, z is equal to 4. Coordinate of this point, x is equal to 0, y is equal to 4, z is equal to 2. That means this is the box, it is lifted. You may write the coordinates of all remaining points and you may think about the integration over all the 6 surfaces as a homework. Thank you.